Now we're going to modify our laser so that it can shoot an arbitrary distance until it hits a target that it can start dealing damage to. To do that, we're going to open up our laser script and we're going to add in two new fields. We're going to start with a direction. So I'll add a serialized field here for direction. It'll be a vector2, and I'll name this underscore direction. And I think by default, I want to just aim this off to the left. So I'll name it, put in vector2 dot left so that it automatically just goes the direction that I'm thinking. But if I want to do a laser that goes up or to the right or anything else, I want to be able to control that. Next, we'll add a field for the distance that I want this to be able to shoot, or a maximum distance. And that'll be a float because it's going to be a number with a decimal point, and I'll call this distance. And I think I'll give this a value of 10 by default. So put in a 10 there, so I can go about 10 meters, and we can adjust this per laser, or maybe come up with a standardized distance for them, or maybe make it infinite so they could shoot off forever. But for now, I'm going to go with a distance of 10, and then we're going to add in our update method. And in the update method, we're going to figure out how far to shoot this laser, and then adjust that line renderer. So let's add a void update. Let it autocomplete. I'll get rid of that private keyword. And the first thing I want to do is figure out an endpoint that is whatever distance away in the direction that we have. So I'll say var endpoint, this is going to be the end of our line renderer, is equal to our transform dot position, so our starting position, plus some offset, which is going to be our direction. We're going to put this in parentheses. We're going to multiply direction times distance. Now this is going to give me an error saying that it can't add a vector2 to a vector3. And the reason for that is that our transform position is a vector3, which means it has that z position in it, while our direction is a vector2, so it doesn't have a z. And when we multiply the vector2 times distance, we still get back a vector2, and it has a hard time adding a vector2 to a vector3. It doesn't know what we want to do, and it thinks, hey, maybe you've made a mistake here. But really what we care about is not the z position of our transform, just the x and the y. So we can actually cast our transform position as a vector2 just by putting vector 2 in parentheses right before it, and what it's going to do is it will treat this transform at this position as a vector2. This only works if the types are convertible. Since a vector2 is just the same as a vector3 without the z, it's able to convert that, get rid of the z, and we just get a 2D x and a y. So we've got that initial position plus our direction times distance to give us our end point. Now we'll set the second point of our line renderer, or position 1, you'll look at the indexes in a second, to that endpoint. So we'll say underscore line renderer dot set position. Yeah, there's a set position and set positions. Set positions allows you to pass in an array of them. Set position is to modify a specific position. We want to modify the second one, which is index 1. Index 0 is the first one. And we want to set the value or the position to our end point. I'm going to save that off. We'll go into Unity, and we should be able to now modify our line renderer just by adjusting the direction and the distance of that laser. Let's play and make sure that that's the case. We'll go select our laser as soon as it starts. And I'm probably going to have to run over there. Let's go turn the laser on. There we go. Turn the laser on. You can see that it's blasting out a beam pretty far to the left. If I drag in this distance, you should see that the distance kind of comes in. If I put it at 3, was it 3? No, it's 4 meters away to that block there. Should work. And if I change the direction to maybe a positive one, it's going to go out to the right. I can drag this out as far as I want. I could even go up and go at some angle, or go like a 0 and a 1 here and have a laser that goes straight up and down. So far, so good. We're getting our laser and it's customizable, but we probably want to make sure that it goes out to a specific target. So to do that, we're going to add in a raycast. We'll open up our laser, and right before we set our position, after we've calculated our default endpoint, let's add a new line. Actually, let's add one more, and then we're going to do a raycast. We'll raycast out in that same direction and see if we can find another target, find that brick or whatever thing is off to the left or whatever direction we end up going. So to do that, we'll assign a raycast hit. So say var, and we'll call this, let's call this first thing. This is the first thing that I've hit, and it's going to be equal to physics2D. There we go. Dot raycast. And we want to give it our origin, which is our transform.position. Then we need to give it a direction, which is going to be the underscore direction. And then finally a distance, which will be our underscore distance. This should return back the first collider that our raycast hits. And then if we find something, we'll say if first thing dot collider is not equal to null. So if first thing dot collider will just be true if we've actually hit something. It'll be false or null if we've not hit anything. So if that is not null, or if we've actually hit something, that's what this is checking. Then what we want to do is set our endpoint to be equal to our first thing, which is, it's not actually the first thing, which is a little bit confusing. It's the first thing's raycast hit 2D. So it's got a little bit of info. It's got the collider, but it also has the point where the raycast hit. So if I set the endpoint to the first thing that I have hit point and save this off, I should now see my laser blast over to the edge or over to this thing and then stop. And then maybe if I turn it the other direction, it should go up until it hits the platform that's moving and then stop. Let's try that out. So I press play. And I'll go turn on my laser so I can see it. And look at that. No matter what I set the distance to, as long as it's greater than 4, it's going to hit that object. And if I change the direction to 1, watch what happens. And let's set that distance out there. Notice that the beam kind of goes and matches with that moving platform. It's hitting that platform. I'm going to put this back to a -1 though, because now I think that we're just about lined up. It's shooting that laser, it's getting it at the right target, and it's ending at the right target, and we're finding the thing that we're hitting. Let's stop playing though, because there's one other problem that we've got here that we haven't addressed yet. We're doing all of this code even if our laser isn't on. Right now we're running this code to do the updates, and we don't necessarily need to. We don't need to be doing that raycast, and we definitely don't want to be damaging things when it's off. And that's what we're going to do next, is write some code to damage things. So let's make sure that we only run this code if our laser is on. And I don't want to turn this script off because that causes some other problems. Instead, we'll just check the is on bool here. So in our update, we'll say if is on is equal to false, then just early exit and return. That's all we need to do. We can quickly bail out and not add some braces and add extra indentation or anything like that. We'll just bail out if our thing isn't on. We'll save, do a quick build, just make sure that all of our files are saved, and then go back into Plastic. And now we have a dynamic laser that hits targets. But dynamic laser that hits and ends at its target. And we'll check that in.